Hello everyone, Applied Mathematics Universe YouTube channel লৈ স্বাগতম জনাইছো মই দিব্যজ্যোতি শইকীয়া মই বৰ্তমান গুৱাহাটী ইউনিভাৰ্সিটি গণিত বিভাগৰ এজন PhD স্কলাৰ হয় এই YouTube চেনেলটোত HS ফাৰ্স্ট ইয়াৰ HS সায়েন্স সেকেন্ড ইয়াৰ এই দুটা ইয়াৰৰ কাৰণে ম্যাথমেটিক্সৰ লগত ৰিলেটেড যিবোৰ টপিক আছে সেইবোৰৰ ওপৰত ভিডিঅ'বোৰ আপলোড কৰা হয় আৰু তোমালোকে যদি HS ফাৰ্স্ট ইয়াৰ সেকেন্ড ইয়াৰ সায়েন্স স্ট্ৰীমত বৰ্তমান পঢ়ি আছা তেনেহলে তোমালোকৰ বাবে এই YouTube চেনেলটো উপযোগী হ'ব so তোমালোকক মই সাজেষ্ট কৰিম যে তোমালোকে এই চেনেলটো সাবস্ক্ৰাইব কৰি লোৱা আৰু লগতে চেনেলটো শেয়াৰ কৰিবা লগৰবোৰৰ লগত যাতে সকলোৱে সমান্তৰালভাৱে ম্যাথমেটিক্স শিকাত সহায় হয় so তোমালোকক মই পুনৰবাৰ কৈছো যে এই চেনেলটোৰ লগত তোমালোকে লিংক আপ হৈ থাকিবা তেতিয়া তোমালোকৰ throughout the HS journey তোমালোকে maths শিকাত কোনো ধৰণৰ অসুবিধা নহয় so thank you for visiting my channel so what is the condition what is the condition for existence of limit so in the previous class we have learned that a function y equal to fx tends to a certain limit L when x tends to a number a arbitrary number a. Again we have also learned the definition of left hand limit. The left hand limit equal to what? The definition of left hand limit is limit x tends to a negative f of x. That means what? When x is approaching a certain value which is less than a, then the function value tends to a certain value and this is called the left hand limit of the function at this point x equal to a. Again, what is the definition of right hand limit? The definition of right hand limit is limit x tends to a positive f of x. That means what? When x tends to a number which is greater than a, then the function value tends to a certain value which is known as right hand limit of the function at this particular point, that is x equal to a. So now if you see left hand limit equal to right hand limit, that means if left hand limit equal to right hand limit, then we can say limit x tends to a f of x exists at in which point? At the point x equal to a. That means what? If left hand limit of the function at a particular point x equal to a equal to right hand limit of the point at the point x equal to a, then we can say the limit x tends to a fx exists at the point x equal to a. So this is the condition for existence of limit of a function at a particular point x equal to a. So now look at some formulas and through which we are going to solve some problems along with this concept of existence of limit. So formula number 1 is what? Note down these formulas by pausing this video, or you can also take screenshot by pausing the video. So formula number 1 is limit x tends to a x to the power n to the power n divided by x minus a equal to n a to the power n minus 1, where n is any real number. So this is the formula number 1 and what is this? Limit x tends to a x to the power n minus a to the power n divided by x minus a equal to n a to the power n minus 1. So if you have this kind of structure in a given problem, then you can directly write the answer n a to the power n minus 1. That means if you have this kind of structure, that means limit x tends to a x to the power n minus a to the power n divided by x minus a, then you can directly directly write the answer of this kind of limit equal to what? N a to the power n minus 1, and where n is any real number. Okay, so next formula is what? Limit x tends to 0 sin x divided by x equal to 0. Okay, so if limit x tends to 0 sin x by x, so this kind of term you get in equation, then you can directly write the answer is what? 0. Number 3 formula is limit x tends to 0 1 minus cos x divided by x equal to 0. Again, this kind of, if you get this kind of structure in a certain problem of limit, then you can directly write the answer equal to 0. And formula number 4 is what? Limit x tends to 0 tan x by x is equal to 0. Okay, so these are the 4 formulas through which we are going to solve some problems. So you can take the screenshot of these formulas, and you can also note down by pausing the video. So look at the problem number 1. Question number 1. Limit, evaluate the limit x tends to 1 x to the power 15 minus 1 divided by x to the power 10 minus 1. So we need to solve this problem. Given limit is what? Limit x tends to 1 x to the power 15 minus 1 divided by x to the power 10 minus 1. Now you observe this function. That means the given function is what? This is of the form x to the power 15 minus 1 divided by x to the power 10 minus 1. Now you also observe the formula which I have already told. So the formula is limit x tends to a x to the power n minus a to the power n divided by x minus a is what? N a to the power n minus 1. So whatever you whenever you get this kind of structure in a problem, so you can directly write the answer n a to the power n minus 1. But for the present case, that means for the present given problem, so we have limit x tends to 1 x to the power 15 minus 1 divided by x to the power 10 minus 1. Now from here, applying the algebra of limit. So what is the algebra? Limit x tends to a fx by gx is what? What we get? We need to separate the limit in the numerator and denominator. Limit x tends to a fx divided by limit x tends to a divided by gx. So this is the algebra of limit for a division of two functions. That means for a rational function, we get this algebra of limit. Limit x tends to a fx by gx equal to limit x tends to a fx divided by limit x tends to a divided by gx. Right? Now by separating this limit, by using this algebra of limit, what do we have? Limit x tends to 1 x to the power 15 minus 1 divided by limit x tends to 1 x to the power 10 minus 1. Now you observe in the numerator what we have? Limit x tends to 1 x to the power 15 minus 1. So now if we want to use this formula, limit x tends to a x to the power n minus a to the power n divided by x minus a, so we need to modify a little bit this numerator and denominator. So how we modify it? Just follow me and you can easily convert this numerator and denominator to this structure of this formula, limit x tends to a x to the power n minus a to the power n divided by x minus a. Just follow me. Now from here on the numerator you observe, so So the numerator can be converted to this structure in this way. Just follow me how we convert it. Limit x tends to 1, x to the power 15 minus, so 1 can be written as 1 to the power 15, right? So it will doesn't sense if you write the power 1 to the power 15, then it will again give you 1. So if we divide x minus 1, then you observe that, then what we observe, limit x tends to 1, x to the power 15 minus 1 to the power 15 divided by x minus 1 exactly look like this formula. Limit x tends to x to the power n minus x to the power n minus a to the power n divided by x minus a. Now in the similar way we can write the denominator also. So how we write, look at this, x to the power 10 minus, so 1 can be written as 1 to the power n, so it can be written as 1 to the power 10. Why? So if you write 1 to the power 10, so again it will give you 1, so divided by x minus 1. So now look at this term and this term will be cancelled out, again you will have this form. So that's why I can plug this x minus 1 and x minus 1. That's why, that means what, since it will be cancelled out after all, after cancelling again we will have this two numerator and denominator. That means limit x tends to 1, x to the power 15 minus 1 divided by limit x tends to 1, x to the power n minus 1. Therefore we can divide x minus 1 in the numerator and in the denominator also. So I hope up to this you have no doubt. So if you have doubt, then you can comment me on comment section. So now the numerator and denominator is completely transformed to this structure of this formula. That means limit x tends to x to the power n minus a to the power n divided by x minus a. So now from here what we can write, so according to this formula we can write n a to the power n minus 1. Here for the numerator, what is the value of n is 15, and what is the value of a is what, 1. So therefore in the numerator we have 15 into 1 to the power 15 minus 1, and in the denominator what we have here, in the denominator what is the value of n, here the value of n is what, 10. So n, what is the value of a, here in the denominator also the value of a is 1, right? So 1 to the power what we have, 10 minus 1. So now from here what we have, 15, 1 to the power 15 minus 1, that means 1 to the power 14, which will give you again 1, and 10 in the denominator of what we have, 10 into 1 to the power 9, which is equal to again 1. So from here what we have, by cancelling by 5, 5 3s are 15, 5 2s are 10. The answer will be equal to 3 by 2, right? So for the given problem the required answer is 3 by 2. So I hope up to this you have no doubt. Again I want to say you that if you have any doubt, then you can comment me on comment section. So I will try to remove all your doubts.